Hi, I'm uCPEs from Telia, and I'm here to talk to you about the PoC we're presenting here, MEF 17, about Agile SD-WAN. The PoC is about Agile SD-WAN deployment and the innovations we're doing 2017 from the MEF 3.0. We are a team of 2 service providers, Telia and Kvantel, and 4 other equipment vendors, Nokia Nuage, OneAccess, RAD and Cisco. So the goals of this proof of concept is to demonstrate how the MEF 3.0 services and the LSO reference architecture will and can enhance the services that we are providing today. So Telia is providing the connectivity services in the Nordics beyond Sweden and Finland. Also Kvantel that has a business of providing access in Norway as a wholesale business, and these are going to boost their services. So we also would like to prove that the utilization of the latest MEF Legato APIs from a multi-vendor that are actually working, and they are going to be demonstrated later by Carl. And last but not least, we are proving the full range of use cases from the SD-WAN White Paper that MEF produced earlier this year. And also one thing that we launched this year, the Carry Ethernet services over LTE, showing that we can do that on demand and provision this over 4G accesses. So this is the setup we have. So on the right side you have Telia's network that is connected to the Kvantel network, and we have 3 sites, one in Finland, one in Sweden and one in Norway. And in the underlay is a Carry Ethernet, and it's the classical services that we are providing today. Then we provision it with the use of the LSO manager, using the LSO Legato, latest definition, part of MEF 58. Then the other underlay was the existing internet that is actually not a new feature, but it's how we launched earlier the SD-WAN services based on best effort as internet accesses. So when we provision the service, then we have the e-access ready, and when it is provided by Kvantel, then we verify the quality of the service, and also not only on the segment but also end-to-end on the SD-WAN service. Then when it's done, we can create actually the SD-WAN service that are using both the internet underlay and the Carry Ethernet underlay. And when it's that working, we can also deploy new virtual functions, like in this case in the PoC we use the VNF from Fortinet for firewall. At this point, Carl will be presenting the demo for WAN, and after that AJ will be presenting the SDWAN Overlay and the virtual service chaining demo.
Well, thank you, Josef. Okay, so moving on to the next part of the demo here, we wanted to show, together with Josef and the team, how we use some of the recent MEF developments to provision MEF services over a multi-segment network. So what we've done is that we have brought the use of the MEF's recently published, actually publicly available, machine-readable specifications of what's called the Legato Interface, okay? So that's actually a big thing for us, because what that allows us to do inside of the time frame of the demo is to literally download that precise, again, machine-readable Yang version of the Legato Interface that also been recently actually published as MEF 58 into our design time tool. And using our zero-code model mapping approach, we can actually drive this through a small CI/CD or build environment or build pipeline, and in literally no time actually provide or produce a standards compliant Legato interface. What's really cool about the Yang approach is that it's not beholden to any particular language bindings or technology choices. So without any coding again, we're able to produce a REST interface, a netconf interface, a couple of language bindings like Java, Python, a CLI, and a web UI. So actually the majority of the work that used to be done manually in a very time-consuming manner can now be done completely automatically by downloading the specifications and putting that into your design time environment. So that actually leaves just a small part of the task at hand in order to again support Josef's demo here. We had to spend some time being able to teach this system how to take orders on the northbound interface and then decompose that into the network here. So we work closely with both RAD and with OneAccess to build a decomposition logic so we can take orders on the Legato interface from the business applications, which is normally an order manager, and actually turn them into, first of all, an internal Presto interface, and then later into the exact ordered set of configuration that we need to provision throughout the network. So I'm going to show you a little bit of the details of this. So as mentioned before, Legato actually, as part of the specification, we now have a formal and machine-readable definition of that. And the structure of that is actually based on three parts. So you got your uni definitions where you define the interfaces. You got your bandwidth profile definitions where you define the profiles of bandwidth that you apply to the unis. And then you tie all this together in the EVC definition. So in order to provision a service, you create a uni, you create a bandwidth profile, and you create, by tying them together, and activate an EVC. And at the heart of the demo, we wanted to show on-the-fly update of the bandwidth profile through this Legato interface. So the literal steps we did here, and I'm just going to show you two of those, is that we cloned the Yang modules. That's the name of kind of downloading the specifications from the GitHub. We loaded them into the orchestrator, automatically generating all the northbound interfaces, and then we added, inside of the 2-week time frame that we gave ourselves for the demo, the Legato to device mapping, including a Presto interface. And so the value of this is a little orthogonal to what others are showing here at the MEF 17. We wanted to show how we can really compress the time frame, leveraging again the machine-readable nature of the Yang modules that has been published by the MEF. So while you'll find other manually developed tools here, we can show from start to finish, less than 2 weeks, picture-perfect Legato compliant interface using two vendors that we hadn't really talked to before. So what I wanted to do with that, I wanted to switch over to our kind of development environment here. And I'll start off by showing you, because this is what I find to be a very fascinating development. This is literally the GitHub site. It's a public site, and as you can see, the MEF now actually has what's called a Git repository here, where they publish, again, the Yang files for the Legato interfaces, the services, and the global definition. So after you've downloaded that, you now, again, have a machine-readable version of the API. So we ran that through a translator into an HTML projection or an HTML version here. So we can actually look at the structure and we can learn how to interact with this. So this is kind of a breadth-first approach, if you like. So it's a very, let's call it rich or flexible set of data models. So there's quite a bit of things to get used to here. So as a programmer, you may want to spend some time here to understand what it is that you can actually do. And the outcome towards the end here, and we're looking at this through what's called a REST client. So it's Postman, it's a REST client. Because of course the consumers of this interface are people in the business application environment, and using REST as an integration technology is the pervasive choice for these guys and girls. And the first thing that I wanted to show here, which I find to be really cool, is that using the standard RESTconf bindings to these Yang modules, you can literally query the orchestrator and ask the orchestrator, what is it that you support? So what you can see here is that the orchestrator that we have built based on these models will tell you that we support Legato, we support the global definitions, and we support the services. So the client on the northbound side, the business application, can actually ensure that the orchestrator actually supports the kind of services that we want to order here. And if we move to some of the REST calls, some of the ways of interacting with this, I'll just show you what it looks like when we put in these calls to the orchestrator here. If we start by looking at the interfaces definitions, so this is the uni definitions, if you like. We can send a new request here, and we'll get back what you will recognize to be a set of unis that are pointing out what devices we're actually running this on. If we then look at the global definitions, we'll see the bandwidth flow parameter profiles, as I mentioned. And then if we end up by looking at the services, you will recognize then, of course, the EVC definitions from the specification, where we tie together through endpoints the unis and we tie them into the bandwidth profiles. So again, the really cool thing here is that we have done this with literally zero coding. All these structures and the content and the validation of it comes straight out of the public GitHub repository published by the MEF. So that allowed us to really put this together again inside of 2 weeks, instead of what's used to be maybe a 12 to 18 months effort. And after having done that, of course, that really polishes the floor and kind of sets the stage for the next step of the demo, which has to do with SD-WAN.
Okay, so as we've seen so far, we've looked at how the underlay network is designed. Now we're going to take a look here at the SDWAN Overlay service that's provisioned across the top of the different underlay networks that we've talked about. So if we take a look here, we have a Nuage physical network function that's deployed in Finland. We have here in Sweden and Norway a virtual network function. Together these are forming the overlay SD-WAN service that's consuming the ELAN connectivity as well as internet underlay connectivity. So I'm going to go to my next slide, which will give us a zoomed in view on the SD-WAN overlay environment. Looking here, we have a physical network function from Nuage deployed in Finland, which is running in a uCPE mode where we have the SD-WAN service deployed as a bare metal environment, and then we have a third-party VNF deployed into the physical network function as well. We do local service chaining in this environment inside the SD-WAN CPE. Here in the pink boxes representing Norway and Sweden, we have the virtual network function deployed on top of the RAD vCPE. Sitting adjacent to the Nuage virtual instance of the SD-WAN CPE, we have a firewall as well. This is where we can do local service chaining as well as remote service chaining. In terms of services that we have deployed on top of the SD-WAN environment, we have a layer 2 service that is spanning here in Norway across to Finland. So we're deploying a VPLS-like service tunneled over the underlays that are available to us. We also have a layer 3 service here, which is spanning all 3 sites, allowing us to have multiple services of different types across both physical and virtual network functions, regardless of where they're deployed. In terms of how we consume the underlay service, we've mapped these ports, virtual ports, onto the physical ports facing both the Kvantel internet, the Telia internet, and the ELAN service. This allows us to selectively map traffic that meets based on SLA requirements onto the underlay that best meets its requirements. So this means if I have multiple classes of service such as platinum, gold, silver, and bronze, I might choose to put the platinum and gold traffic mapped directly onto the ELAN service unless it has degraded out of service tolerances for the overlay service. So whilst we're already running performance management in the underlay, the overlay service is also able to test and understand how well that underlay is performing between the CPEs. So this means we can protect against any issues that might occur in the underlay that could impact the overlay service itself. We can also directly offload traffic to the internet. So if we have traffic like YouTube or other SaaS applications that we want to directly send to the internet, we might choose to service chain that through the virtual firewall and send that traffic directly out to the internet, a mode known as internet offload or internet breakout. So this allows us to more efficiently use the different underlays that are available to us. All of this is managed by the control infrastructure, which for this proof of concept was driven out of a Nokia facility in Portugal, really bringing the multinational capabilities to light here. So we have our directory, which is where we define all of our enterprise tenants and their services, layer 2, layer 3, the security rules, and also where we capture analytics from the network. We have our controllers, which actually instruct the CPEs on how to build the topology for both the layer 2 and layer 3 services. And then we also have a customer-facing portal, which is really how our end customer interacts with the service. So looking here, this is the customer dashboard. So this is what the customer is experiencing their SD-WAN overlay service as. So here we can see that we have the 3 sites across Norway, Sweden, and Finland that are up and online. And we can see that right now we don't have too much traffic because this network has been running without traffic load on it. So here I'm going to dig into some of the dashboards that customers can see inside the product. And I'm going to choose some of our historical views here where I have traffic that was generated previously in the environment. You can see here that we've just brought up a dashboard covering the last 14 days worth of traffic analytics. We can see here that we had some very simple layer 3 test streams, and then we also have some application traffic that was recognized. This is highlighting the application-aware capabilities of SD-WAN, and we can, for instance, choose application-based traffic steering, such as redirect YouTube directly onto the internet connectivity, or we can associate HTTP with a class of service that requires it to go across the ELAN service as a primary. Other capabilities of customer interaction are digging into the branches that we have and reviewing the status of the CPEs, whether they're physical or virtual. All of this status is collected frequently and presented to the control infrastructure, and this allows us to see, for instance, that this port here is green and this is the network that is provisioned on that port. I can then go into a VPN view and see the actual different layer 2 or layer 3 VPN services that are being provisioned for, in this case, my MEF conference customer tenant. We can see here that I currently don't have any specific security rules defined, but I would define and deploy security rules here, and they would be pushed by the infrastructure to the CPEs, allowing real dynamic management of the enterprise VPN service. Here we see another logical representation of the different sites connected in Zone 0. I'm now going to switch over to the service provider view, which allows operators like Telia to dig into more detail around how they define performance management criteria that customers can consume. So in here, I'm looking directly at the management plane of the platform. So this is on our virtualized services directory. And this is where I see my MEFConf tenant. I can see the templates which have been consumed by them to instantiate services, such as the MEF L3 VPN service that we have here. And as you can see, this is really just representing the same topology that the customer sees in a slightly different view. So we represent Sweden, Norway, and Finland here as the sites. So on the topic of VNFs, we'll dig in a little bit more about how they're defined and consumed by the operator and made available to the enterprise to deploy, and then how we can use performance metrics. So we'll see here that we have our NSGX in Helsinki, which has a couple of ports associated to the firewall VNF that's deployed on that CPE. Here we see that we have a VNF instance. We can see here which CPE that it's deployed to and the type of VNF. And over here we see the status of the VNF instance, that it's running and available. So we define a template of a VNF that's available, and we allow customers to consume that onto their CPEs. We do some validation checks to make sure that the CPE has sufficient resources, and then we deploy the VNF and attach it into the customer's network. Looking now at performance management of the overlay, here is where we define our network performance measurement probes. You can see here that we have a probe that's defined, it's a performance monitor, and this is currently sending 1 packet per second across the overlay in a service class that we're measuring for performance for. So this might map to different classes of service available on the underlay. For instance, what we call service class H might map to the AF forwarding class available or class of service available on the network underlay. This allows the overlay to understand the end-to-end performance between the virtual and physical CPEs in the SD-WAN environment, and we can make a routing decision based on that. Customers can associate applications to different classes of service that have different performance criteria, including probe rates and things like packet loss and latency requirements. And that concludes how we handle performance measurements and monitoring in the SD-WAN overlay. And now back to Youssef to conclude.
So, as you've seen from the demo, we have these different vendors, the multi-vendor environment, that are doing different things. So, One Access is providing the carrier Ethernet access services over 4G, mobile accesses. Nokia Nuage, they're providing the SD-WAN solution. RAD are providing the universal CPE NID solution. Cisco is providing the automation and orchestration solution using the standard Legato Young module. And our services provided by Telia and Kvantel are interoperable carrier Ethernet services, CE 2.0, including end-to-end and per segment verification with L2 service activation test, and performance management between the endpoints RAD and WAN access. So in conclusion, from this PoC is that we wanted to show what are the new innovations that MEF have as part of the MEF 3.0 from 2017, and the PoC demonstrates and validates the MEF vision with these innovations. Thank you.